Our next speaker will be Sello Kakana. Sello was born in Kabudi village, South Africa, which lies within the Ivanhoe Mines Platreef project area, close to the project. He holds a national diploma in geotechnology and a Bachelor of Technology degree from the Geology of Sewanee University of Technology and a Master of Science degree in Geology from the University of Witwatersrand. Sello started his professional career in mineral research and then worked as a geotechnologist for the groundwater company. In 2003, he joined Ivanhoe Mines and has worked on projects in South Africa, the DRC, Democratic Republic of Congo, and Zambia. Sello played a key role in the discovery of the Flatreef deposit, advancing from geologist to project manager to general manager to group manager geology to head of transformation. Sello managed the deep drilling, which during his tenure expanded to 30 drill rigs that delineated the Flatreef deposit. Since September 2017, he has been head of the technical training and development for Ivan Platts. In 2017, Sello and Dr. David Broughton were awarded the Colin Spence Award by the Association for Mineral Exploration in British Columbia for their roles that led to the discovery of the Tier 1 Flatreef underground deposit.
Thanks, Ken. With that introduction, please allow me to take you back to South Africa for now. How does this work?
Okay, that's the advance, back, and laser.
Okay. Okay, in South Africa, the Bushveld Complex comprises of main three limbs. Is the eastern limb, the western limb, and the northern limb. The different colors here shows the different mining companies who occupy licenses along these limbs. And the Bushveld Complex, as you might know, is the main producer of the platinum minerals in the world, and we produce about 75% of that. Our project is located in the northern limb, around about here, and to the north of us, we've got Anglo Platinum's mining operations, and over here we've got Lonmin's Akanani project, and further north up here, we've got the Waterberg project where PTM is holding licenses there, and we've just heard last week that Impala Platinum has also bought some shares in this, a stake in this property up here. Now, because of the depth of the Merensky Reef and the UG2 in both the east and the western limb, some mining companies are suffering to stay alive, and as a result, they are looking towards the northern limb to try and make things work. That's why we see Impala Platinum buying a stake in the Waterberg project. But because of the resources that we have seen so far in the northern limb, we believe that the northern limb will become the future of South Africa's platinum industry. Zooming in into the Platreef, or the northern limb, our mining license are shown by this dark blue color. It's on Turfspruit farm in Makalakaskop, and the blue is Anglo Platinum's mining operations. And up here is the Akanani project where AfriOre started to drill the deep drilling project, which is down deep from Anglo Platinum's mining operations. This red line here shows the Platreef ore body, sub-outcrop. So zooming in onto the Platreef mining license, as I've indicated, we've got two farms here, and the drilling, exploration drilling started in the year 2000. The first hole was drilled in October, and at the time we were looking at shallow resources that could be mined via open pit methods. And from the year 2000 up until 2003, we've completed a total of 563 holes, producing 187,000 meters of drill core. And all these black dots are the holes that we've drilled during that period. And we've defined an indicated mineral resource within this blue or purple line here, which had 520 million tons of 0.86 grams per ton PGEs. However, a significant portion of the resource underlay a community of about 3,700 households, which would have had to be moved in order to make way for the open pit. And we also had some challenges with the metallurgical recoveries at the time. So between the year 2004 to 2006, we engaged in a program where we were doing the re-logging, reinterpretation, and remodeling of the resource with the hope of trying to improve the mineral grades and the metallurgical recoveries. At the time, during 2006, when we were doing all this re-logging, AfriOre was drilling further north from us, about 20 kilometers north, as I've indicated in the previous slide, to the west of Anglo Platinum's mining operations. And this section shows the Anglo Platinum's open pit over here, and this red line shows the boundary between Anglo Platinum's properties and AfriOre's property at the time. So they could map that the Platreef was dipping gently from the Anglo Platinum properties into the Akanani property. And they've intersected mineralization from depths of 800 meters from here, and then down here it was about 2 kilometers. So when we decided in 2006 that the open pit was not going to be profitable, we also took the same approach that AfriOre did further north. And we said, okay, let's look at the potential from down deep areas of our open pit. And on this map, the open pit would be somewhere around here. And the blue area shows all the indicated resources that were drilled over the time, and the green area is the inferred resources in blue, the indicated resources in green. So in 2007, we drilled our first hole run about here, down deep from the open pit, and we've intersected the high-grade mineralization at a depth of about 955 meters. And the top section of the Platreef returned about 10 meters of 4.7 grams per ton PGEs, 0.41% nickel, and 0.2% copper. And the third hole was drilled around here, further south, a kilometer away, or a kilometer and 60 meters away from the first drill hole, and this one intersected a high-grade mineralization within what we thought was, or below what we thought was the bottom of the Platreef. And this one intersected 10 meters of 12 grams per ton PGEs at 1.8% nickel and copper combined. And because of the low grade that we were used to from the open pit drilling, these two results generated an excitement on the project, and we were given additional money to drill holes. But because of the high grade that we've intersected in the third hole, we were forced to focus in this area for the rest of 2009 program. So, however, during 2008, we drilled a number of holes along strike up to northern Turfspruit, and we've intersected some good mineralization in some of the holes up here, but we didn't follow up on those holes. We instead focused on the southern Turfspruit for the entire period of 2009. At the end of 2009, we've defined 700 million tons in this area over here, of 1 gram PGEs and about 0.24% nickel. However, at the base of this area, we've intersected some high-grade mineralization where we had some intersections ranging from or about 87 meters at 0.5% nickel and 0.5% copper. And when we decided that this was not going to be feasible to start a bulk mining operation, we then moved further north where we had previously intersected some good mineralization. So in many discovery projects, you often hear of the discovery hole being mentioned. However, on this project, in order to define the Flatreef, we needed at least a minimum of 4 drill holes. The holes in green, I can safely say that these were the discovery holes. So this hole, UMT7 and 33, were drilled in 2008, and both of them had intersected the Platreef at similar depths. And the high-grade mineralization we saw there occurred within similar rock types, which is the pegmatoidal peroxenite, and below it was the pegmatoidal hasbergite. When we came back in 2010, we drilled these holes, UMT40 and 35, 200 meters down deep from each hole, and we also intersected the contact between the main zone rocks, which were the gabbronorites, and the critical zone peroxenite at similar depths that we've intersected in these holes. And the high-grade mineralization was continuous in these holes, and also it was sticking within the same rock types. So we then asked ourselves, how are we going to predict further where the Flatreef could be? And that's when we involved our in-house geophysicist. At the time, it was Barry Devet and Nick Williams, who is somewhere in the audience here. Hi, Nick. So we asked them to invert the magnetics data that we had, and we also had some limited gravity on the project, but they started to look at the magnetics data, and while they were doing those magnetics inversions, we also planned these holes, which are now 400 meters down deep, and these holes also intersected the same mineralization that we saw in these holes and within the same rock types as well. So Nick and Barry's work resulted in the following. Here we're looking at the vector remnant magnetic inversion map, where the section you see on the right-hand side is shown by the the red line across here. The black line shows again the Platreef sub-outcrop, and this higher anomalies here represents the Penge iron formation. Down here we've got the main zone gabbronorites and norites, and then here we've got the upper zone rocks. So this inversion was based on the contrast between the main zone gabbronorite susceptibilities, which were about 2.2, versus the 10.7 susceptibilities within the critical zone peroxenites and lower zone peroxenite. So as a result of the modeling that they've done, we could predict that the contact between the main zone rocks, which forms the hanging wall to the reef, and the Platreef rocks were more or less at this depth. So the blue and the green would represent the main zone rocks, and all the hot colors would represent the Platreef. From the last hole that we had drilled at that time, these inversions indicated that there is a potential that the Flatreef could be extending further west for about 1 kilometer. Following this, we then made a simple map indicating where the potential Flatreef could be based on that 1 kilometer that we saw from the inversion map. This area in light gray here, this is where we thought the Flatreef could be. So we put in a couple of holes, we drilled them here, and then while we were drilling additional holes, we defined an inferred resource within the the green rectangle here, and this had 17.8 million tons of 4.6 grams per ton PGEs and 0.41% nickel and 0.19% copper. And this encouraged the Japanese company Itochu to buy a 2% stake on the project worth of $10 million US. And with that money, we were able to extend the drilling program to drill these additional holes you see here. And you can see outside the inferred resource that we had defined, we also had holes that intersected high-grade mineralization ranging up to 46 meters of 5.7 grams PGEs. So by March 2011, we took all this information, we put it into the model again, and we were able to increase the inferred resource by tenfold from 18 million tons to 180 million tons at similar grades. And this also was exciting to the Japanese. They called in their friends, JOGMEC and JGC. They bought an additional stake of 8% on the project worth $280 million. After we got that investment, a decision was made to convert all the inferred resources into indicated resources. And to do that, we were given only a period of 8 months. So we got the word from Mr. Friedland saying we need to define indicated resources by end of the year. And in order to achieve this, we brought on site 30 drill rigs from 5 different drilling companies. We were using 4 assaying laboratories, both in South Africa and Australia. We had about 12 geologists logging and interpreting core, and we were producing about 10,000 meters of drill core every week. At the end of that program, we were able to define 214 million tons of indicated resources at 4.1 grams per ton PGEs. And this is shown by this area here, that 214 million tons. So all the black dots you see in here are part of the 413 holes that we drilled during that program over this area. So the information we got from this drilling program, Nick took it and put it into the magnetics, and he further indicated that the Flatreef, the mineralization was extending potentially into these areas out here. And we put in a couple of holes here and we've intersected that mineralization. So when you hear of the Flatreef, this is how it looks like. This area, the green indicates the main zone gabbronorites, which is the hanging wall, and these holes to the left, to the right here would indicate the open pit resource holes, and all the holes from this fault to this side are the deep drilling holes. The area that we're gonna be mining, which we represent the critical zone, which is really the pyroxenites and gabbronorites and hasbergites, is this area over here. And with the modeling that Nick did, we were also able to identify this area where mineralization is continuing. So that's the Flatreef within the Platreef. So why do we compare ourselves to the mining companies in the east and the western limb? Well, if you look at the grades that they are mining, they get about 4 to 10 grams per ton PGEs, and then we have an average grade of 3.8 grams per ton. However, their thicknesses is about 1.5 meters thick, which is, if you look at this guy, this would be the floor rocks, and above his head is the hanging wall, and all he's trying to mine is this 1 meter thick reef. Whereas if you compare that with at least one hole that we have on our property, this is an intersection of 25 meters thick, grading at almost 10 grams per ton PGEs, and almost 0.5% nickel. And one line in this core box represents 1 meter, which is about the thickness of what this guy is looking for here. The mineralization occurs in the form of chalcopyrite, pentlandite, and pyrite, but the PGE mineralization is not hosted within the sulphides. It's hosted within the antimonites, arsenites, bismuthites, and tellurites, which are difficult to recover. So then in 2012, we flew a Falcon gravity gradometer survey. What we're looking at here in the green is the area that we covered with the survey, and the yellow dots are all the holes we drilled during the 2011 drilling program, and this is where the Flatreef was defined. And the gravity survey, the green lines here represent the contours of the invasions that we've done. And where the contours are steep, are close to each other, it represents the steeping of the dip, where the dip of the reef is steep, and where the contours are apart from each other represents where the reef is flat. So this was also part of Nick's job, where he looked at the density of the main zone rocks, which is about 2.91, versus the density of the critical zone peroxenites, which is about 3.2. And in addition to that, he used the physical property, the density measurements that we had taken on the drill course from the main zone into the Platreef or the critical zone. He integrated that into this model, and eventually we were able to identify that the Flatreef actually continues further south. And then in 2013, we put in a couple of holes here just to prove that it is indeed flat and it is still mineralized, and we found that this was the case. And in fact, this area is much shallower than the initial flat reef that we've discovered here. The top of reef here is about 600 meters deep. So we didn't follow up on the drilling that we've done down here, because the area that we've defined, the indicated resources that we've defined here to date, is about 346 million tons, which if we mine at a 4 million ton per annum operation, we can mine this area for the next 90 years. So there's no need for following up on this target at the moment, but if we need to expand the mining operations, we know which direction to follow. So if you look at yesterday people were asking about how do we integrate the physical properties into the magnetics inversion. This is what happens. This map shows the default gravity inversion, where there was no constraining by geology at all. In blue and green is supposed to be the main zone rocks, and all the lines going down is the drill holes, and here you're looking at the platinum grades on those drill holes. But if you take into consideration the density measurements that we had collected on the drill core, you come up with a figure like this. So you are able to make sure that all the readings that you have on the drill core matches the readings that you have in the model. So you can see now the main zone is represented by the green, and then all the critical zone and the lower zone peroxenites are now falling within the reef, where it's represented in the hot colors. Some of these holes are off section, that's why they would seem as if they appear in the main zone, but that's not the case. So if you were wondering about the scale of the area that we've drilled up to now, it is almost the size of the lower Manhattan city in the States. So why do we compare ourselves to the east and the western limb? Again, their reef thickness is about 1 meter thick, and in that area we've defined indicated resources. We have about an average of 19 meters that we'll be mining. They use conventional mining methods, we're gonna use mechanized methods. Their labor force is about 20,000 people, and then we're looking at roughly 2,200 people. Mining cost per ounce of platinum produced, they're looking over $1,000, where we're looking at a potential $351. So if our mining is going to be phased in 3 scenarios. The first phase will be the 4 million ton per annum operation, where we aim to produce 476 million tons of PGEs, and that will make us number 6 in terms of global production. And if we go to 12 million tons per annum, we'll become the world's producer in the world. So unfortunately, I've ran out of time, but in terms of the success factors that led to the discovery of the Flatreef, a huge credit goes to the support that we got from the Ivanhoe management. If it wasn't for the courage that Mr. Friedland had on this project, the project was supposed to be shut down in 2004 when we decided that the open pit was not going to work. And we also had some support, financial support from our Japanese partners, and of course the integration of geology and geophysical data. And the team that we had at the time, logging 10,000 meters of drill core every week was not easy. And of course we had to get some cooperation from the local authorities and communities. And as they've said, in January this year, myself and my partner in crime, Dave Broughton, who is your fellow countryman, we were awarded with the Collins Pence Award for the role that we played on the discovery of the Flatreef. Thank you.